Hello everyone, we are RoomDreaming, generative AI approach to facilitating iterative preliminary interior design exploration. Interior design is a process from A to B with the goal of developing aesthetically pleasing and functional environments. So how do we go from A to B through this process? Between the original space and the final design, there are numerous design possibilities. Owner undergoes multiple iterations, exploring various divergent design directions and gradually converging to the preferred design in the owner's mind. However, in the current process, it typically takes at least 6 to 15 weeks, and even with this considerable time investment, the design results are not always satisfactory. When exploring designs, most people start by opening an image search engine, just like Pinterest, to find the design they prefer. However, the first challenge they encounter is that the layout in the reference image may not match the original space, and it can be difficult to visualize how the same design would look in their original space. When go-to designers, the designer utilizes diverse approach to understanding owner's preference and requirements. They interpret and gauge owner's preference through various cues such as body language, verbal description, emotion, or hobbies. For instance, if an owner mentions minimalist design, there are various interpretations of this concept, leading to discrepancy between the owner's and designer's idea, causing communication challenges. In the current preliminary design process, designers invest several days in developing each alternative involving decision on shape, color, and materials, followed by plan arrangement, 3D modeling, and rendering. However, this approach is really time-consuming and costly, particularly due to the extensive 3D modeling required. Despite the effort, designers continuously identify owners' needs and assess design alternatives during collaboration. However, with typically only 2 to 3 owner design meetings, with designer creating 3 to 9 design alternatives occurring over 6 to 15 weeks, homeowners still struggle to fully explore their design ideas and convey preference effectively to designers. So we present RoomDreaming, generative AI approach to facilitating iterative preliminary interior design exploration. Our insight is to leverage generative AI's ability to rapidly generate vast design alternatives and to tailor it to support the inherent iterative nature of early-stage interior design exploration. Additionally, we combine the advantage of human designer to ensure the quality of the designs and the exploration process. We conduct a series of formative and summative studies with a combined total of 18 homeowners who had completed design project or were planning to design a space but had not finalized their design directions, and 20 interior designers with a combined professional experience of 112 years. The first, second, and fourth studies help us to define the design goal and iteratively improve the system. Furthermore, the study of self-guided exploration and owner-designer co-design study help us understanding the potential improvement of exploration process and iteratively improve the RoomDreaming system. Our design goal is to empower users to efficiently broaden the scope and depth of their design exploration and to facilitate communication with the following sub-goals. First of all, to help users to experiment and access design ideas, systems need to generate designs based on the original room image. Secondly, in the context of interior design, owners from our formative study report limited knowledge of possible design styles or terminology to express what they desire. So the system needs to expand the breadth of users' design exploration with the various design directions. Finally, it's crucial for aiding owners in exploring the design space, making decisions, and ultimately converging toward a final design. So users can indicate preferred design and then prompting the system to generate more alternatives with the similar design directions. Additionally, control their design process by adjusting the proportion of the design with new direction in the next iteration from divergence to convergence. With the advancement of generative AI for image and text, particularly the release of Stable Diffusion and ChatGPT in 2022, several generative AI products have launched that allow a photo or a 3D model of a space being used as an input and then generate reference design in a variety of styles such as Iterative or RoomGPT. However, generating images that match the actual space is a critical first step forward, but existing approaches don't allow users to specify preference for further iteration and explore designs in depth. In RoomDreaming, the system architecture includes three main components. First is the web-based user interface. Second is backend to generate design alternatives, consists of an image analyzer, prompt composer, and design generator. And the third is the large language model for providing new design directions. When a user inputs an image, the system employs segmentation and depth estimator to analyze it. The segmentation estimator categorizes objects within the scene, assigning different color to each element for semantic information. Meanwhile, the depth estimator creates a depth map of the 3D space, indicating proximity to the camera with lighter shades and distance with darker shades. This map illustrated the size, shape, and spatial relationship between elements within the space. To generate photorealistic interior design alternatives based on the segmentation and depth maps, we employ Stable Diffusion and Generative AI model that produce unique image from text and image prompts, and also ControlNet, a neural network structure capable for conditionally controlling diffusion model during image generation. After image analyzing to support independent design exploration of varying adherence level to existing elements and spatial information, users can independently specify the adherence level implement using the control weight parameter in ControlNet. To expand breadth of user design exploration, when users start to explore design, system will generate 20 designs per iteration. Furthermore, instead of generating design only within the scope of user-specified prompts, the 20 designs are generated by user-specified requirements plus 20 different design directions generated by large language model. To supporting depth of exploration, when users found their preferred design direction, they can indicate preference via like and bookmark, and the LLM proportion of prompts corresponding to like and bookmark designs are stored as preferred prompts. Furthermore, system will generate new design alternative within the design direction by using the preferred prompts to help user experiment and make the further design decision. To enable users to control the exploration process, users can also control the ratio of new and preferred design directions in the next iteration. Therefore, users can flexibly and rapidly explore the design iterative from divergence to convergence. To understand RoomDreaming's user experience for self-guided design exploration by owners, we conduct this study. In this study, RoomDreaming was compared to two baselines using within subject design for each. In the first baseline, participants freely choose their preferred existing tool just like Google Image and Pinterest. The second baseline involved AI generation without iteration support, which comes with RoomDreaming UI and features except for two key iterative design features. For example, liking and bookmarking no longer affect prompts, and the new design direction slider was removed. For each conditions, participants spend 20 minutes exploring designs for their project, and they would be interviewed after completing the exploration. In order for the design exploration to be part of a real interior design project, we recruit 12 owners, 6 for each baseline, who plan to design a space but hadn't finalized their design directions. The following charts representing the overall preference on design exploration efficiency and satisfaction, with the color gray representing the baseline and orange representing RoomDreaming. Furthermore, the breadth and depth of exploration using a 7-point Likert scale, where dark gray indicates strongly prefer the baseline and the dark red indicates strongly prefer RoomDreaming. In the two baseline, most of the participants prefer the efficiency and satisfaction of RoomDreaming, as each participant was able to explore up to 120 designs in 20 minutes, and most of them found their most preferred design when using RoomDreaming. Notably, in the baseline of existing tool, some participants specifically mentioned that while 20 minutes was insufficient for design exploration using existing tools, but it was adequate when using RoomDreaming. In the baseline of Generative AI, participants prefer RoomDreaming for depth of exploration as it empowers them to expand on ideas they like to test them. Here's the case study of one of the participants from the study with the existing tool baseline, and it's the original image, room image, and the participant provide for designing a living room. Firstly, here are the likely image collect using Pinterest, showed a wide range of design ideas and not integrate and also not match the participant's room. In contrast, the design generated by RoomDreaming not only match the participant's room layout, but also offer breadth of options in first iteration. This breadth allows the participant to discover a preference for both color. Furthermore, like design direction from early iteration continue into further iteration, helping him solidify his preference. By the 5th iteration, after reviewing 100 designs within 20 minutes, he bookmarked and found the most preferred design. On the other side, here's the case study of one of the participants from the study with generative AI baseline. Over first, third, and fifth iteration, the baseline AI continued to exhibit divergent design direction even in the 5th iteration. In contrast, RoomDreaming showcased converged to owners' desired design direction by 3rd iteration, and in the 5th iteration, such as variation within the preferred design direction. And the participant also mentioned that the new lightproof material was unexpectedly well suited for her room. To evaluate RoomDreaming's potential improvement on communication issue between owner and designer, we conduct the study of owner-designer co-design exploration. In the study, to simulate the current initial discussion process, pairs of owner and interior designer discuss basic requirements for 10 minutes and collaborate use RoomDreaming for 6 minutes to achieve a mutually satisfactory preliminary design direction. And because of the asymmetry in prior collaboration experience, with this designer have had worked with many owners versus owner have only limits or no prior experience, our interview additionally asked designer to compare using RoomDreaming to their current practice. In order for the design exploration to be part of a real project, we recruit 6 participants with 3 owners and 3 designers. Designers report that in the current process, it typically took a week to create 3D models based on owner requirements, with additional time needs for re-rendering after meeting for request change totaling up to another week. In contrast, RoomDreaming saved up to 15 working days due to its instant generation of designs and increased precision in capturing owner preference through multiple iterations. Furthermore, designer opposite owner using RoomDreaming could quickly identify their needs and preference. This accelerated pace also enable designer to initiate discussion on assessment and feasibility, including budget and construction. So here's the demo video. Thanks for your listening.